Here's a GRE data analysis question. Let's take a look. Set S consists of non-zero numbers W, X, Y, and Z. Set T consists of non-zero numbers 2W, 2X, 2Y, and 2Z. So we want to know what's greater, the standard deviation of set S or the standard deviation of set T. All right, so on the GRE, you have to understand the concept of standard deviation, but you don't actually need to know how to calculate it. And this question is a case in point. We don't actually need to know how to calculate the standard deviation. We just have to understand what standard deviation is. So if you're not super familiar with that, I would encourage you to review it, but I'll give you a very quick and dirty explanation right here. The standard deviation of a set basically describes how widespread it is. That's not a perfect explanation, but for instance, if I have a set where all the numbers are concentrated around one, point, the standard deviation is going to be very low. But if I have a set where all the numbers are kind of spread out, the standard deviation is going to be higher than that. And this is a quantitative comparison. So we're comparing this set, numbers W, X, Y, and Z, to numbers 2W, 2X, 2Y, and 2Z. Well, at first glance, you might want to say, well, yeah, quantity B is greater because if I multiply all the numbers in a set by 2, they're going to get more spread out, whether they're positive or negative. But there's one case we need to consider. What if W, X, Y, and Z were all the same number? And I'll be very specific here. I'm going to use a case where, let's say there's 0, and W, X, Y, and Z are all 1. So it's 1, 1, 1, and 1. Well, that would mean that set T, 2W, 2X, 2Y, and 2Z, would be 2, 2, 2, 2. 2, 2, 2, 2. And the standard deviation of both of these sets would be 0. So the fact that I can find that counterexample means that the correct answer here is D. It's possible that this set is greater than that one. However, it's also possible that they are equal. So the correct answer here is D.